So once we've got everything working with the pre-built executables, and the reference firmware that comes preloaded on the VP430's QSPI, the next thing to do is to rebuild the reference firmware. And so if we navigate to the Abaco directory, common firmware extracted 755 VP430 AXI, where we have the zip of the reference firmware, copy that over to your build machine, wherever that might be, which I have done here. So here's the zip. I unzipped it, and I'll just give a quick overview of the directory. There will be a tickle file here that is used to script together a top-level Vivado project. There's a doc folder which contains top-level documentation for the reference design. So CD in this case stands for Constellation document, so it's Constellation 755. There's an IP directory which contains all the Abaco IP used in the design. So if we pick an example, the capture IP, there's also a document folder which contains star documentation, SD, all the source, as well as the simulation. So if I go back up to the top here, so this is described in CD 755, but in order to generate the Vivado project, we're going to want to call this tickle script from within Vivado. And the release notes we're checking out specify that Vivado 2018.2.1 is the supported Vivado version. So I have Vivado 2018.2.1 open. I can go to Tools, Run Tickle Script, and specify the 755 VP430 AXI project tickle script. So if you click OK, that'll create this VP430 AXI directory and we'll script together a top-level design. I've already done that because it takes a few minutes, so I'll click Cancel. And here we can see the top-level block design for the VP430. And so this is a mix of Xilinx IP and Abaco IP. If I zoom in down here, there's a sub-block which contains the Xilinx RF data converter IP block. So we can click on that and see how it's configured. So we have all ADC channels configured for a 4 gigasample per second sample rate. Multi-tile synchronization is enabled. By 8 decimation is configured for the ADC's digital down converter. The first Nyquist zone is specified. Yeah, and all ADCs are configured the same way. On the DAC side, we have it configured for 6.4 gigasample per second sample rate. Multi-tile synchronization is also enabled, and we also have 8x interpolation for the DAC's digital up converter, and once again, the first Nyquist zone is selected. So I'll cancel out of that. Everything in here is intended as a reference and to be modified and adjusted as necessary for users' application. So once you have, so probably on the first pass, you're not going to want to change anything. Just generate bitstream. You also want to rebuild the RFSoC Zinc images. So boot.bin image.ub. And so to do that, you'll probably want to go to File, Export Hardware. This will export an HDF, which the PetaLinux tools will then take in and will be used to rebuild the Zinc's boot images. So that process is somewhat time-consuming and is actually very well documented in our Getting Started guide. So if I switch back over to the test machine, and I go to the documentation directory. So the VP430 Getting Started guide has a whole chapter, chapter 6, dedicated to rebuilding the Zinc image. And so I'll just direct your attention at this point to this section in the documentation. It should be pretty easy to follow. And so by going through the steps outlined in this chapter, you'll be able to rebuild the Zinc boot images. Once those are created, so that'll take an hour or so depending on your machine, at least on the first time you build it, you'll want to reprogram the Zinc. So we have so if you have a RTM 311, that can be you can put the the updated boot.bin and image.ub boot images on an SD card and boot from SD card. However, if you don't have an RTM, rear transition module, you can navigate to VP430 Standard Development Kit, bins, and within bins is VP430 QSPI programming. So I'll just print out the usage instructions here. This utility can be used to update the Zinc boot images, and there's some examples of, do you want to do this with over the PCI Express interface or the Zinc interface? You just provided a path to the boot.bin and image.ub that you want to program onto your QSPI. So once that's done, you can then reboot the Zinc and make sure that the reference software, which is also in bins, right here, VP430 RefApp, make sure that that still runs. Now you know that your build process is functional, and you can start making modifications to the reference design. So that's it on this section of the Getting Started video.